Okay, let's close Chrome here. And there we see, still waiting for us in the command window version of the help page for plot. No matter how you get the help page, if you scroll down here at the bottom, you usually find See Also list. Here's plot 3. I wonder what that is. Let's click that link. Plot lines and points in 3D space. That seems pretty cool. Let's suppose that that's sort of what I was looking for. The other thing I might do is look at an example. I find it's easier to be introduced to a subject by an example than theory anyway. That's really why this course is like that. Let's show you how easy it is to try an example. I'm going to copy this thing. Here's copy. Then I'm going to paste it into the command window. And it runs. That's the way all plots work. They pop up in a separate window called a figure. See here, figure 1. This plot does look three-dimensional. It's supposed to be a helix. But is it really 3D? Well, you can't use, the 3D glasses with it, but you can do something just as good. I'm going to click this little circle thing here and look at this. You can look at it from any angle. And that makes it pop out. Makes it look very 3D. To me, anyway. By the way, if I click somewhere in this command window, this thing disappears. And if that happens to you, don't worry. It's back here. It just went to the back. You can always get it back that way. Okay, that was fun, but I'm going to close this. We're going to be a little less ambitious and go to 2D, because that's what you'll want 99% of the time. And let's plot just 3 points on an XY graph to get the idea. Okay, let's clear everything using clear and CLC. There. Now, the first thing we need to do to plot something is to specify the X and Y coordinates for the points we want to plot. And here's how we can do that. And the next thing we do is run the plot function, like this. And there's our plot. Before we go further, let me show you how you can keep this nice figure from disappearing back there behind the Matlab desktop when you click in the command window. You just click this tiny arrow right here. And the figure suddenly shows up in its own little window right here in the Matlab desktop. It's called docking the figure. Okay, let's see what we did to get this plot. Command window is just this little thing down here now. And we can see the first command, set the variable x coordinates equal to a list of 3 values, 1, 3, and 10. Well, let's stop right there. A variable has 3 values at the same time? Well, actually, x coordinates has just 1 value. It's this whole thing here. Its 1 value is a vector. And we get a vector by typing these left brackets and right brackets. We'll go into detail on that later. But a vector is just an ordered list of numbers, 1, 3, 10 in this case. Those numbers are called the elements of the vector. We did the same thing for the y coordinates. And here's the first point. X equals 1. X is plotted along the horizontal axis. And y equals 2. There's the 2. Then there's a line drawn to the second point. You can see that x is equal to 3. And y looks like it's probably equal to about 4.2. And here's the last point. X equals 10, y equals 12.3. When we typed x coordinates and y coordinates in parentheses after the function name plot, it meant that the values in those variables were inputs to the function. Inputs to a function are called input arguments in programming, or just arguments. Plot expects to get 2 vectors as input, and they have to have the same number of elements, 3 in this case. In Matlab terminology, the number of elements of a vector is called its length. For you physicists out there, the length of a vector is the square root of the sum of the squares of the elements. And there's a Matlab function called norm that will give that to you. But to get the number of elements in the vector, you use a Matlab function named length, like this. So the value of the variable x-coordinates is a vector of length 3 whose elements are 1, 3, and 10. When we entered those elements, you may have noticed all those commas. Before now, the comma had been used only to separate 2 commands on the same line. Now we see a second use, separating elements in a vector here and here, and a third use, separating the arguments to a function here in our call the plot function. The plot function gave us a nice plot, but to tell the truth, it's not quite what I wanted. Instead of this jagged blue line going from point to point, I wanted to plot each point separately. Well, the plot function will do that for us if we know how to tell it to. We do that by giving it a third argument. Let's call it again, but slow down a bit as we type. P-L-O-T, left paren. After that first parenthesis, this thing pops up. It's called a hint, and it reminds you of the various arguments that you can feed it. I say reminds you because you really need to know how it works for the hint to be much help. I happen to know that the third argument here, this second option, called line spec, is the so-called line specification argument, and you use it to tell plot how to plot your points. Let's do it this way. This quote asterisk quote tells plot to put an asterisk at each one of the points instead of a line connecting them. So now I'm going to hit enter. And there we go. Here's a point here, here's a point here, and there's one there. An asterisk usually means multiply, but this asterisk has single quotes around it, as you can see, and that changes its meaning. A single set of quotes around characters tells Matlab not to treat those characters as the name of an operation or a variable or a function. Instead, it treats the characters between the quotes as just a string of, well, characters. And it's in fact called a string. To remind you that it's a string, Matlab highlights it in that purplish pink color that we saw before. Or would you call that lavender? And speaking of color, let's alter our plot by changing the color and, while we're at it, the shape of the points that we're plotting. Let's go back to the help page to see how to do that. I'm going to use the doc command because I have so little space in my tiny command window with this figure taking all this space. Doc plot. Here we go. 2-line plot. What I'm looking for is something about line spec. Oh, here we go. Line spec. Let's see. I can specify a solid line by using a minus. These are the things that go in those little quotes instead of the asterisk. Here's a dashed line and so on. The marker I'm looking for is a square. There we go, square. So I use an S for that. What about the color? Oh, here's the colors. Yellow, magenta, well, red is an R. Okay, so now I know what to do. What I'm going to do, hit the up arrow key to repeat this command. I'm going to go up to there. And I'm going to alter this by putting in, what did we decide? Red square. You can put an RS or an SR, it doesn't make any difference. Now watch these little asterisks, these blue asterisks, change into red squares when I hit return. 4, 3, 2, 1, there. And there you have it. There's those little red squares. There's other ways to enhance these plots too. For example, we can add a grid with the grid on command. There we have a nice grid. And you can probably guess that you can turn it off with the grid off command, but we're going to leave it on. And we can add labels to the axes like this. Let's add one to the x-axis. X label. Let's just make up something. Say selection. See, that shows up right away when we hit selection. And Y label. That's going to be change. There's our Y label. And what about a nice title for this thing? Title is the name of that command. Changes in selections during the past year. And there it is. Here we've got three more functions that use strings as arguments. We've seen plot puts a string here, and there's a string, there's a string, there's a string, just a string of characters. And they're all colored this color, whatever it is. And it's the same color that's used here and used here when you give arguments to the dock, the grid, and other commands. Matlab automatically chose the ranges in this plot. It chose 1 to 10 for X, the horizontal axis, and -6 to 14 for the vertical axis. But you can change these ranges with the axis command. Let's do that. Before I hit enter, I'm going to talk about what we've done here. Axis takes a 4-element vector, 1, 2, 3, 4 elements. The first element is the left end of the horizontal axis. That's going to become 0. The right end is going to be 12. The bottom end of the vertical axis is next. That's going to be -10. And then the upper axis limit is going to be 20. So watch this. I'll hit return. You'll see these change. So now we go from 0 to 12 and -10 to 20. Just what we asked for. Well, that's about it for plot. There are other plotting functions too. There's one called bar, which produces bar graphs. Let's try that next. Note that the bar graph replaced the previous plot. And we see here at the positions of X, 1, 3, and 10, the heights of the bar match the Y values. 2, -4.2, and 12.3. If you don't want the second plot, the bar for example, to replace the first plot that you were looking at in the figure, you can ask for a second figure. You type figure, like this, and it gives you a new figure. Let's put something in that figure. I'm going to dock it. And what I'm going to do is put a pie chart in there using the function called pie. Pie takes one vector as an argument. I'm just going to make one up. Note that we separated the elements of this vector with spaces instead of commas. Yep, you can use spaces or commas or both. Each element in the input vector, the 4, the 2, the 7, the 4, and the 7, determine the size of one slice of pie. So now I'm going to hit enter and see what we get. I'm going to pick some colors for each slice, and it calculates the percentages of the sizes of each slice relative to the whole and shows them for each slice. And there you go. To close a figure window, you can use the close command. To close figure 2, you use close 2. And that leaves us with figure 1. We could close figure 1 with close 1, but you can always close all the open figures with close all. So I want to show you that one. And there, we're back to no figures. Before we finish looking at figures, let's put up one last one. This time we're going to display a photo. Over in the current folder window here, we see that there's a file named palace.jpg. You're probably familiar with this. JPG, it means that this file contains a photograph stored in a very common format. It's called the JPEG format. So the first thing we need to do is load this photo that's in this file into Matlab, and we can do that with a command called mread. So I'm going to type that in. And the argument I give it is the name of the file in quotes, like this. You have to use uppercase where there's uppercase in the file name. And so now I'm going to hit return, and there we... Okay, not good. We need to stop this. It doesn't hurt anything, but it won't stop for a couple of minutes, and we don't have time for that. Do you remember how to stop Matlab? Control-C. We press the Control key. While we're holding that down, press the C key. There. That's over. What happened is that the mread command found the file, read the numbers inside it just like we wanted it to, but then it poured those numbers out into the command window, and there are a lot of numbers in there, over 47 million of them. What we should have done is tell Matlab to assign the output of mread into a variable instead of pouring it onto the screen. We should have used an assignment statement like this. I'm going to assign it to a variable called pretty picture. Sheesh, are we ever going to get this right? Control-C again. This time we forgot to put a semicolon at the end of the line. So after it stored the data in the variable pretty picture, and we can see up here that it did that, there's a lot of data there. 3,456 by 4,000 times 3, that's a lot of numbers up there. We'll learn what all this means in the next lesson. But what we should have done was put that semicolon in. Let's do that and repeat the command. Okay, 3's the charm. The picture is captured in the variable pretty picture, but we haven't seen it yet. So how do we look at it? Well, we can do that with a function named image, like this. It is a pretty picture, but we don't need those numbers on the edges cluttering it up. Let me dock this thing, and I'm going to give a command called axis off. There, much better. Matlab can display images in lots of formats in addition to JPEG, and it allows us to do image processing on all of them too. We'll look at that in a later lesson, but now let's end lesson 1 and let's quit Matlab while we admire this photograph. It is beautiful, isn't it? I'd tell you who shot it, but modesty forbids me. Okay, to quit, we give the quit command. Here we go. Q-U-I-T, return. Matlab is gone, and we're back to our computer desktop where we started from. We could also have quit by just closing the Matlab desktop by clicking the little X in the upper corner, but in either case the desktop closes and all the figures close as well. When Matlab leaves, it puts everything away. And it's time for us to leave too. That's the end of lesson 1.